Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we embark on a contemplative meditation across deep time, watching Mars transform from frozen desert to living world. Not as urgent escape plan, but as patient exploration of possibility, experiencing centuries flowing like moments as ice melts, water returns, and green life spreads across red stone. So settle into your most comfortable position, close your eyes, and prepare to experience transformation at planetary pace, where decades pass in breaths and patience becomes peace. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. Just as Mars will transform gradually over centuries, you transform gradually now. Each breath releasing tension, each moment settling deeper into calm. No urgency, no rushing, just patient, natural progression toward rest. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls, how air flows effortlessly in and out, how your body knows how to rest without conscious effort. Inhale patience itself. Hold this peaceful moment. Exhale urgency completely. Feel stress leaving your body like atmosphere escaping to space, drifting away, leaving you lighter and calmer. With each breath, you release a little more into relaxation, settling into this journey across time. You're standing on Mars today. Jezero Crater, same landscape Perseverance rover explores. Rusty red regolith stretching to horizon. Temperature reading through suit sensors, -80 degrees Celsius, late afternoon in Martian winter. Air pressure, 610 pascals, less than 1% of Earth's 101,325 pascals. Atmospheric composition, 95% carbon dioxide, 2.7% nitrogen, traces of argon and oxygen. Unbreathable. Pressure too low for liquid water, below the triple point of 611 pascals, where water exists only as ice or vapor, never liquid. Sky above you, butterscotch tan, dusty salmon pink near horizon. Sun, smaller disk than Earth's sun, 60% apparent size, pale and distant. Mars orbits at 1.52 astronomical units, receiving only 43% of Earth's solar energy. Landscape around you, ancient river delta, frozen for 3 billion years, rocks scattered across dust, distant crater rim purple in thin atmosphere. Silence absolute, no wind strong enough to hear through this thin air, no water flowing anywhere, no life stirring. Mars rejecting human presence through sheer environmental hostility. You think, could this frozen desert ever be green? Could water flow here again, the way it flowed billions of years ago when this delta formed? Could I breathe this air without suit, without helmet, walking freely under open sky? Not today. Not in your lifetime. Not in your children's or grandchildren's lifetimes. But perhaps, if patience deep as geological time were applied, if generations committed to planetary gardening, if humanity chose to become gardeners of worlds rather than just visitors, perhaps Mars could live again. Tonight, we explore that patient possibility. The question isn't, should we terraform Mars? That ethical debate comes later. Question first, could we? What would transformation require? How long would it take? What methods exist? What challenges prevent it? Let's explore the science before considering the choice, understanding the magnitude of planetary gardening, the patience required, the processes involved. Not as fantasy, but as contemplation of real proposals based on physics, chemistry, biology, all grounded in scientific understanding. Let the technical details wash over you like gentle waves, informing imagination, supporting peaceful contemplation. Temperature baseline establishes the challenge. Mars averages -63 degrees Celsius globally. Earth averages +15 degrees Celsius. Difference, 78 degrees, requiring massive heating. Variation extreme. Equatorial summer daytime reaches +20 degrees Celsius. Comfortable shirt-sleeve temperature if air were breathable. Polar winter nighttime plunges to -125 degrees Celsius, colder than Earth's Antarctica record of -89 degrees. Thin atmosphere provides no thermal inertia. Temperature swings 60 to 100 degrees between day and night at same location. Terraforming would moderate extremes by thickening atmosphere, increasing heat retention. Atmospheric pressure challenge is fundamental. Current 610 pascals insufficient for liquid water existence. Need minimum approximately 1,000 pascals for water stability in warm regions, nearly doubling current pressure. For breathable atmosphere, humans need 15 to 20 kilopascals oxygen partial pressure. Earth provides this at 101 kilopascals total pressure, with 21% oxygen. Mars could provide at approximately 50 kilopascals total pressure if oxygen percentage increased, 40% oxygen at 50 kilopascals gives 20 kilopascals oxygen partial pressure. Breathable, though requiring careful balancing to avoid oxygen toxicity at high percentages. Complex engineering, but physically possible. Magnetic field absence complicates terraforming. Mars lost global magnetic field 4.2 billion years ago when core solidified, convection ceased. Earth's magnetic field deflects solar wind, charged particles streaming from sun at 400 kilometers per second. Without magnetic protection, solar wind interacts directly with upper Martian atmosphere, stripping lighter atoms to space at rate of approximately 100 grams per second currently. Over 4 billion years, this stripped most of Mars's original atmosphere, estimated 1 to 3 bar initially, reduced to current 0.006 bar. Terraforming concern: will enhanced atmosphere be stripped away? Analysis suggests atmospheric escape occurs over 10 to 100 million year timescales, slow enough that civilizational maintenance could compensate. But Mars provides resources for its own transformation. South Polar Cap contains 3 to 4 trillion tons of frozen carbon dioxide. If sublimated to gas, would double atmospheric pressure to approximately 1,200 pascals. Still only 1.2% Earth pressure, but enough for liquid water stability in warm regions. North Polar Cap, 1.6 million cubic kilometers of water ice, sufficient to cover planet to depth of 11 meters if spread uniformly, or create ocean covering 1/3 of surface to depth of 30 meters if concentrated in northern lowlands. Subsurface ice detected at mid-latitudes, depth 1 to 10 meters. Water exists, frozen, awaiting warmth. Resources sufficient, awaiting human patience and will. First warming method: super greenhouse gases. Perfluorocarbons like carbon tetrafluoride and sulfur hexafluoride are 10,000 to 25,000 times more potent greenhouse gases than carbon dioxide per molecule. Atmospheric lifetimes of thousands of years. Proposal: manufacture these compounds on Mars using indigenous fluorine from minerals, release into atmosphere. Small quantities, 0.1 to 1.0 parts per million concentration, could raise surface temperature 10 to 30 degrees Celsius over several decades. Manufacturing requires energy, nuclear reactors or vast solar arrays, plus fluorine mining, processing, continuous production over decades to maintain concentration. Advantage: targets atmospheric chemistry directly, no megastructures required. Challenge: enormous energy requirements, sustained industrial effort across generations. Orbital mirrors offer another approach. 100+ kilometer diameter reflective mirrors, thin aluminum-coated mylar, total mass approximately 200,000 tons, launchable from Mars's moons Phobos and Deimos, which may contain useful materials. Positioned at Mars orbit, focusing additional sunlight onto polar caps. Additional solar input of 20 to 30% could raise polar temperatures above -78 degrees Celsius. Carbon dioxide sublimation point, triggering greenhouse effect as frozen carbon dioxide enters atmosphere as gas. Engineering challenges. Mirror stability, requiring active station keeping with ion drives. Deployment of 100-kilometer structure. Long-term maintenance. Benefits. Reversible if needed. Adjustable to focus different regions seasonally. Potentially faster than chemical methods. Decades versus centuries. Carl Sagan proposed the simplest method in 1973. Distribute dark material over polar ice caps, carbon black, Martian dust, engineered nanoparticles, or dark pigmented extremophile microorganisms. Reducing albedo from 60 to 70% down to 10 to 20%. Physics. Absorbed energy equals solar constant times 1 minus albedo times surface area. Reducing albedo from 0.65 to 0.15 increases solar absorption by 143%, potentially raising surface temperature 20 to 30 degrees locally. Simplest method: aerial dispersion, robotic spreaders, or biological, dark bacteria colonizing ice. Slowest approach requiring sustained effort over centuries, as new ice exposed beneath darkened layers. But technologically modest, achievable with current era technology. Asteroid and comet redirection offers dramatic possibility. Small asteroids or comets impacting Mars deliver kinetic energy, volatiles, and heat. Impact energy equals 1/2 mass times velocity squared, with velocity approximately 5 kilometers per second for Mars intercept. Example: 10-kilometer diameter comet, mass approximately 5 times 10 to the 14th kilograms, impacting at 5 kilometers per second, delivers approximately 6 times 10 to the 23rd joules, equivalent to 100 million megatons, vaporizing impactor plus significant Martian surface material, creating temporary steam and carbon dioxide atmosphere in region. Challenges: requires ability to redirect asteroids using gravity tractors or propulsion. Precise targeting. Many impacts needed for sustained warming. Public acceptance of planetary scale bombardment. Possible, but complex. Energy requirements are staggering, but calculable. Sublimating south polar carbon dioxide requires approximately 10 to the 16th joules, comparable to world's total nuclear arsenal detonated simultaneously. Warming planet, manufacturing greenhouse gases supporting growing population, industrial processes, all require sustained energy across centuries. Energy sources available. Solar power. Mars receives 590 watts per square meter versus Earth's 1,361, reduced but usable with vast arrays. Nuclear fission, using uranium and thorium deposits detected by orbiters. Nuclear fusion, if achieved, deuterium available from water, lithium from crust, virtually unlimited energy. Order of magnitude. Warming poles via greenhouse gas production might require 10 to the 14th to 10 to the 15th watts, sustained for decades. Comparable to current human civilization's total power consumption. Demanding but achievable for spacefaring civilization, with centuries to scale up. Now let time begin to soften and flow. You close your eyes for a moment. When you open them, 10 years have passed. Decade gone in a breath. Standing at same location, Jezero crater, temperature reads -79 degrees instead of -80 degrees. 1 degree, barely measurable. Polar factories have been producing greenhouse gases continuously, tons per day, every day, accumulating parts per million in atmosphere. Instruments detect change. Perfluorocarbon concentration 0.3 parts per million. Atmospheric temperature rising 0.05 degrees per year. Trend established. Process begun. Patience required. This is century-long project, measured in degrees and pascals, not days and dollars. Another breath, another decade. 20 years gone. Temperature -78 degrees. South polar cap subliming slightly faster. Carbon dioxide ice turning to gas at edges. Atmospheric pressure increasing from 610 to 630 pascals. 20 pascals gained. Trivial, still far below liquid water threshold. But direction correct. Engineers monitor. Warming rate matches predictions. No unexpected complications. Infrastructure maintained. Energy supply steady. Nuclear reactors operating reliably. Solar arrays collecting thin Martian sunlight. Fuel reserves sufficient for decades more. You settle deeper into patience. This work continues long after you're gone, carried forward by children, grandchildren, generations unborn. "50 years, half-century, dissolves while you rest. Temperature at Jezero, -73 degrees, 7 degrees warmer than start. Pressure, 720 pascals, 18% increase. Polar ice retreating visibly. Satellite imagery shows South Cap smaller, darker patches, where ice sublimated, exposing darker subsurface layers. Carbon dioxide entering atmosphere, accelerating warming. Greenhouse feedback beginning. Each degree gained sublimes more carbon dioxide, which causes more warming, which sublimes more carbon dioxide. Positive feedback loop initiated. Critical threshold approaching. Once polar temperature exceeds -78 degrees, runaway effect possible. Rapid release of remaining polar carbon dioxide over decades instead of centuries. "75 years pass like extended sleep. You wake to changed world. Temperature -65 degrees, 15 degrees warmer than baseline -80. Pressure 850 pascals, 40% increase from start. Visible atmospheric thickening, sky slightly hazier, dust storms more vigorous, stronger winds possible in denser air, occasional clouds. Water vapor from subliming ice forming wisps. Still harsh, temperatures far below freezing, pressure inadequate for liquid water, air unbreathable, but trending. First-generation terraformers, those who built initial factories, released first greenhouse gases, are elderly or gone. Second generation maintains work, seeing grandfather's vision approaching fruition. Third generation will see water. "100 years, full century. Longer than human lifespan, but blink in geological time. Temperature at Jezero, -35 degrees, 45 degrees warmer than start, halfway to freezing point. Pressure, 1,200 pascals, double original 610 pascals, exceeding triple point of water. South polar carbon dioxide cap nearly gone, sublimed to atmosphere, causing pressure doubling and additional greenhouse warming. In warmest regions, equatorial summer afternoons, Hellas Basin at -7 kilometers elevation, where pressure highest, temperature reaches +5 degrees, above freezing. Water ice melts. You're standing at edge of Jezero ancient river delta, summer afternoon, year 100. Temperature +2 degrees. Pressure 1,300 pascals, locally higher in crater depression. Air still unbreathable, pressure still far too low for unprotected human, but you see it, dark patch on slope. Wet soil, liquid water seeping from subsurface ice deposit, melting for first time since this delta formed 3.5 billion years ago. Not flowing, just seeping, darkening regolith, collecting in tiny puddles, but liquid. You kneel, touch through glove, feel moisture. Mars's ice remembering how to be water. Days later at same location, seep has grown to trickle. Trickle has cut tiny channel, water flowing down slope. Centimeters per second, modest flow, but moving. Gravity pulling water toward ancient delta floor, where vast lake once existed. You follow water's path, seeing it carve miniature canyon through dust, exposing bedrock, creating first erosion Mars has experienced in eons. Water disappears into sand, absorbed by dry regolith, evaporating into thin air. But during flow, Mars lives briefly. Hydrological cycle attempting to restart. Ice melts, water flows, some evaporates, some seeps underground. Nighttime temperatures refreeze surface. Next day melts again. Incomplete cycle, but beginning. Year 120. First persistent water body. Small lake in Hellas Basin, deepest point on Mars. Depth 3 meters. Surface area 1 square kilometer. Fed by melting ice from crater walls, maintained by pressure 1,800 pascals at -7 kilometers elevation, high enough for stability and seasonal warmth. Summer temperatures +10 degrees. You stand on shore, actual shore, water lapping at boots, small waves driven by thin wind. Water clear, no life, no sediment yet. Pristine, cold at +4 degrees, near freezing, but liquid. Martian lake. First standing water in 3 billion years. Mars remembering what it was, becoming it again. Another century flows past. Year 200 now. You rest deeper, time becoming flexible, decades and years merging. Temperature at Jezero, -10 degrees average winter, +15 degrees peaks summer. Pressure 2,500 pascals, approximately 2.5% earth pressure. Humidity increasing, water evaporating from expanding lakes, melting ice fields, entering atmosphere. Sky changing, occasional clouds, wispy at first, then more substantial. Cumulus formations appearing over warm lakes, convection lifting water vapor, weather systems attempting to organize. You're standing in Ma'adim Vallis, ancient river valley carved 3.5 billion years ago, 800 kilometers long, dry since formation. Spring afternoon, year 200, temperature +8 degrees. Ground trembles subtly. You look upstream, water. Spring emerging from canyon wall, aquifer activated by subsurface melting, pressure forcing water to surface. Trickle becomes stream, stream becomes flow, water volume increasing as more springs activate along valley walls. Within hours, river flowing, cutting channel through dust, following ancient valley floor toward Gusev crater. Mars's first river in 3 billion years. Week later, same valley. Flow has strengthened. River 5 meters wide, half-meter deep, flowing 2 meters per second. Slower than Earth rivers due to 38% gravity, but substantial. You walk beside it, watching water carve banks, transport sediment, create first fresh erosion features. Ancient valley remembering its purpose, water returning to paths carved eons ago. Geography encoding memory, water flows where water flowed before, continuity across billions of years. Rivers of distant past flowing again in patient present, time collapsing, Mars healing across eons through gentle human intervention. Then, milestone you've been anticipating. First rain. Clouds darkening over Valles Marineris Canyon system, year 215. Water vapor condensing around dust nuclei, droplets forming, growing, falling. Light drizzle initially, evaporating before hitting ground. Then heavier precipitation, droplets reaching surface. Rain on Mars. You stand in it, faceplate beaded with water, watching puddles form. Hydrological cycle complete. Evaporation, condensation, precipitation, collection, evaporation again. Mars has weather. Rain falls, rivers flow, lakes grow. Water spreading across planet like slow stain, reversing 3 billion years of desiccation through patient human intervention. Year 300. Temperature plus 5 degrees average, plus 25 degrees summer peaks at equator. Pressure 5,000 pascals, approximately 5% earth pressure. You overlook Valles Marineris, vast canyon 4,000 kilometers long, up to 7 kilometers deep. Canyon floor, water pooling, creating long, narrow lakes stretching hundreds of kilometers. Lake shores, green. Not bright earth green, but dull olive-brown green, but unmistakably alive. Cyanobacteria, seeded decades ago, spreading wherever liquid water exists, forming mats on rocks, coating lake bottoms, floating in water columns. You descend to canyon floor. Elevator from rim settlement connects to growing biosphere zone. Approach lakeshore. See bacterial mats beneath clear water. Green film covering submerged rocks, bubbles rising. Oxygen from photosynthesis. 6 carbon dioxide plus 6 water plus light produces sugar plus 6 oxygen. Coverage still sparse. Cyanobacteria occupy approximately 1% of planet's surface, concentrated in warmest, wettest regions, but expanding 10% annually. Growth follows water. Riverbanks green, lake shores green, moist soil patches green, spreading like slow moss across red rock. You kneel at water's edge, see bacteria up close. Layered mats, stromatolites forming. Same structures Earth's cyanobacteria created 3.5 billion years ago, now recreated on Mars. Slimy texture, faint organic smell detectable through suit filters. Life. Mars lived once, perhaps, evidence ambiguous, 4 billion years ago, died when atmosphere stripped away. Now lives again through deliberate human introduction. Question arises, is this authentic Mars life or imported Earth life? Answer, both. Bacteria earthly in origin, but Martian in residence, adapting to different gravity, sunlight, atmospheric composition, evolving into Martian organisms over generations. New evolutionary trajectory beginning. Oxygen production measurable now. Instruments measure atmospheric oxygen at 0.1% concentration. Still insignificant compared to Earth's 21%. Still unbreathable, but detectable above trace amounts. Production rate 10 to the 15th grams per year, accumulating linearly as bacterial coverage expands. Breathable atmosphere 15 to 20% oxygen at target pressure requires 10 to the 20th to 10 to the 21st grams total, meaning 500 to 1,000 years at current production rate. Timeline extending into deep future, but process underway. Green spreads molecule by molecule, breath by microscopic breath, oxygen accumulating in atmosphere, like interest compounding over centuries. Year 500. 5 centuries since terraforming began, 15 to 16 human generations committed to project. You wake from long rest, time having flowed around you like water. Mars transformed visibly. From orbit, planet shows blue patches, oceans, seas, lakes. Green patches, vegetation zones. White patches, smaller polar caps, water ice dominated. Brown-red patches, remaining bare regolith, still majority of surface, but shrinking annually. Temperature, plus 10 degrees average, plus 30 degrees summer peaks. Pressure, 15,000 pascals, approximately 15% earth pressure. Oxygen, 5% concentration, still unbreathable, but approaching levels where ozone layer begins forming. You're standing on shore of Vastitas Borealis Ocean. Northern lowlands flooded over past 2 centuries, water now covering 30% of planet's surface, depth 100 to 300 meters. Waves lap at boots, actual ocean waves, wind-driven, rhythmic, hypnotic. Sky, salmon pink transitioning to pale blue overhead. Thicker atmosphere scatters light differently, approaching Earth-like Rayleigh scattering, but dust still present, giving characteristic Martian tint. Clouds substantial, cumulus formations, weather systems, occasional thunderstorms visible on horizon, lightning in Martian sky, electrical discharge through increasingly conductive atmosphere. Vegetation everywhere. Cyanobacteria mats, now ubiquitous near water, covering approximately 15% of planet's surface. Joined by mosses carpeting rocks, engineered for cold tolerance, low pressure, thin air. First experimental grasses in sheltered valleys, bamboo species, tough and fast-growing, spreading in Hellas Basin lowlands. Lichen covering boulders, symbiosis of fungi and algae, extremely stress-tolerant, colonizing from coasts to highlands. Green extending from water bodies outward, 50 kilometers inland from ocean shores, 10 kilometers from riverbanks, coating slopes facing equator, receiving most sunlight. Planet slowly greening, life claiming Mars, 1 meter at a time. Rain frequent in tropical zones. Equatorial belt receiving monsoons, seasonal heavy precipitation. River systems flowing year-round, fed by rain and melting ice. Waterfalls forming over cliffs, flowing gracefully in 38% gravity. Different aesthetics than Earth falls, more languid, more dreamlike. You stand beneath waterfall in Valles Marineris, 100-meter drop, water falling slowly enough to track individual droplets. Mist rising, rainbow forming in spray, sun illuminating scene with pale amber light. Beauty unexpected. Mars becoming aesthetically appealing, not just scientifically interesting, worthy of contemplation, not just study. Year 800. 8 centuries. Time losing meaning. You've rested through so many decades they blur together. Transformation feeling inevitable now, rather than uncertain. Temperature, plus 12 degrees average, plus 32 degrees peaks. Pressure, 30,000 pascals, approximately 30% earth pressure. Oxygen, 12% concentration, approaching breathable. Need approximately 15% oxygen at this pressure for comfortable breathing. Coming close, threshold visible ahead. You're walking through forest. Actual forest, trees 10 to 15 meters tall. Species, pines, engineered for Mars conditions, cold tolerant, low pressure adapted, efficient photosynthesis. Birches, fast growing, adapted to thin soil. Genetically modified sequoias, experimental, thriving in Hellas Basin warmth. Understory, shrubs, heather, low bushes, ferns, primitive plants doing well in Martian conditions. Ground cover of moss and grass. Soil beneath, real soil now, not just regolith. organic matter from centuries of decomposing plant material, microbial activity, earthworm action. Earthworms introduced to aerate soil, decompose organic matter, crucial for soil development. Overhead, birds, sparrows, engineered for thin air, enhanced lung capacity, more efficient oxygen exchange, larger hearts relative to body mass. Flitting between branches, songs echoing through forest. Martian birdsong. Insects, bees pollinating flowers, wildflowers growing in understory clearings. Butterflies, monarchs, genetically modified for low-pressure flight, thriving. Beetles decomposing fallen wood, ants building colonies in soil. Full ecosystem developing, primary producers, plants, primary consumers, insects, herbivores, secondary consumers, insectivorous birds, decomposers, fungi, bacteria, earthworms. Trophic levels establishing, energy flowing through food web. Mars supporting complex multi-species communities. Stream flowing through forest. Clear water, cold at +8 degrees. Fish visible. Trout, cold water species, introduced for protein source and ecosystem completion. Adapted for lower oxygen levels, thriving in clean Martian streams. You kneel, watch fish swim. Effortless movement through water, bodies sleek, healthy. Aquatic ecosystem functional, algae coating rocks, insects, mayfly larvae, caddisfly nymphs hiding in gravel, fish feeding, nutrients cycling. Mars has fish. Impossible statement just centuries ago, reality now. You remove helmet briefly. Risky but possible for limited time. Air, cold at +10 degrees, thin. 30 kilopascals pressure equals approximately 8,000 meter Earth altitude equivalent. Oxygen poor. 12% oxygen gives approximately 3.6 kilopascals oxygen partial pressure. Breathable with difficulty, like summit of high mountain. First breath of Martian air, crisp, clean, cold in lungs, oxygen barely adequate. Brain slightly hypoxic, thinking fuzzy, breathing heavy. Can't sustain this for hours, need helmet for prolonged activity. But breathing unassisted possible for minutes. Threshold approaching where helmet becomes optional rather than mandatory. Freedom from confinement within sight. Year 1000. Millennium. 33 human generations working toward this moment, each contributing, none seeing completion in their lifetime, all trusting process. Temperature, +14 degrees average, Earth-like. +35 degrees summer peaks, -20 degrees winter lows. Seasonal variation remaining due to orbit and axial tilt, but within terrestrial range, comparable to Earth's temperate zones. Pressure, 50,000 pascals, approximately 50% Earth pressure, half of sea level, but sufficient for human comfort with adaptation. Oxygen, 18% concentration at 50 kilopascals pressure, equals approximately 9 kilopascals oxygen partial pressure. Humans ideally need 16 kilopascals, but 9 kilopascals survivable, equivalent to 8,000-meter Earth altitude. Permanent Martian residents adapt over generations. Born Martians have enhanced lung capacity, efficient oxygen utilization, thriving in thin air. You're standing in Martian meadow. Grass, terrestrial species, engineered varieties. Wildflowers, poppies, lupins, daisies, all adapted. Butterfly feeding on flower, monarch, wings iridescent in Martian sunlight, genetically modified for thin air, successful introduction. No helmet, no suit. Light jacket against cool breeze at plus 12 degrees, comfortable. Sky, blue. Pale blue overhead, thin atmosphere, less scattering than Earth. Salmon pink near horizon, dust never fully eliminated. Mars retains identity despite transformation. White clouds drifting, cumulus, fair weather, beautiful. Breathe deeply. Air thin but breathable, fresh, scent of grass and distant water. Lungs work harder than Earth, noticeable, like being at altitude, but sustainable indefinitely for adapted residents. In distance, forest, pines, birches, stand of sequoias, hills rolling toward horizon, stream flowing through valley, settlement visible. Dome-free buildings. Architecture now includes open windows, balconies, outdoor gathering spaces, no pressure differential to seal against. Overhead, Earth visible as bright evening star, blue-white point, magnitude -2, brighter than any star except Sun, Venus-like brilliance from Mars. Origin world, home of ancestors, still populous and thriving presumably, but no longer humanity's only home. 2 living worlds now, 2 biospheres, backup for life, insurance against extinction, expression of human capacity for patient transformation. You lie in grass, feeling soil beneath, real soil, organically rich, supporting diverse life. Watching clouds drift, breathing Martian air freely for first time in human history. For first time in Martian history. If Mars never had breathable atmosphere, even 4 billion years ago, when warmer and wetter. Millennium of patience culminating, Mars transformed, humanity expanded, second living world created through multi-generational cooperation. Greatest engineering achievement in human history. Greatest biological introduction ever attempted. Greatest expression of human patience and vision. And you breathe it, simply and freely, lying in grass under blue Martian sky, held by transformed planet, embraced by possibility realized. Contemplate what this transformation required. Not one genius, not one government, not one lifetime. Generational commitment. Generation 1, year 0 to 30, built factories, released greenhouse gases, saw no visible results, worked on faith that grandchildren's grandchildren might see green. Generation 10, year 270 to 300, saw first green patches appearing, walked beside first rivers, knew their grandchildren might breathe easier. Generation 20, year 570 to 600, walked in young forests, swam in growing lakes, oxygen levels rising but still suited. Generation 33, year 960 to 990, removed helmets, breathed freely, completed work their ancestors began. Each generation contributing, none seeing completion in their lifetime, but trusting process. Like medieval cathedral builders, masons laying foundations, knowing their great-great-grandchildren would place spires. Working for future, not personal glory. Legacy, not immediate reward. Mars terraforming as multi-generational project, teaching patience, delayed gratification, civilization-level cooperation. Long-term thinking absent from quarterly earnings culture, election cycle politics, instant gratification consumerism. But humanity capable of this patience when properly motivated, when project noble enough, when vision compelling enough. You realize, not can we afford it, but can we afford not to ensure our continuation by becoming multiplanetary, spreading life beyond single planet, creating redundancy against extinction. Cost, trillions of dollars, thousands of years, countless lives devoted to project never seeing completion. Benefit, surviving as species, expanding consciousness to multiple worlds, learning to garden planets, becoming truly spacefaring civilization capable of multi-generational thinking. This patience, watching decades flow, centuries accumulate, transformation unfold at planetary pace, mirrors the patience required for falling asleep. Both require releasing urgency, trusting process beyond conscious control, accepting that meaningful change occurs on timescales exceeding immediate attention span, surrendering to larger rhythms. As Mars warmed gradually, you relax gradually. As atmosphere thickened over centuries, your breathing deepens over minutes. Transformation and rest, parallel processes, both requiring patience, both ultimately peaceful. Question arises: should we terraform Mars? Not could we, clearly possible given time and resources, but should we? Does humanity have right to transform planet? Arguments for preservation. Mars has intrinsic value independent of human use, deserves protection as wilderness, as scientific preserve, as monument to planetary processes. If indigenous Martian life exists, subsurface microbes in aquifers, deep caves, terraforming would destroy unique evolutionary lineage, irreplaceable biology. Once terraformed, pristine Mars gone forever, irreversible change, permanent alteration. Arguments for expansion. Becoming multiplanetary ensures human species survival against extinction risks. Asteroid impact, nuclear war, climate catastrophe, pandemic, any single planet disaster. Terraformed Mars enables experiments impossible on Earth, scientific opportunities, new societies, cultural diversification. Humans are tool makers, transformers, gardeners. Engineering planets reflects our nature not as passive observers, but active participants in cosmos. If Mars confirmed sterile through exhaustive exploration, decades searching for life, then no indigenous biology harmed by transformation. Synthesis. Explore thoroughly first. Decades of missions searching every plausible habitat for life. Subsurface aquifers, caves, polar ice, deep regolith. Proceed only if Mars confirmed lifeless. Maintain preserves of original conditions. Protected regions never terraformed, preserving unaltered Mars for science and heritage. Recognize decisions' gravity, requiring global consensus across generations, not rushed choice, but deliberate commitment over centuries. If we terraform, do so carefully, respectfully, acknowledging responsibility for maintaining what we create. Tonight, not advocating for terraforming as necessity, not presenting as urgent escape from dying Earth. Earth remains supremely habitable compared to Mars, protecting Earth far easier and more important than terraforming Mars. Instead, contemplating possibility, exploring science, experiencing imaginatively what patient, multi-generational transformation might achieve. Whether we should remains open question. That we could, given patience deep as geological time, seems increasingly clear. Lying in Martian meadow, year 1500. Transformation continuing beyond breathable threshold. Ecosystems complexifying. New species introduced. Climate fine-tuning ongoing. Dusk approaching. Sun setting. Smaller disk than Earth's sunset, but familiar after generations. First stars appearing. Then, Earth rising above eastern horizon. Bright blue-white star, magnitude -2.5, brightest point in night sky except Sun and occasionally Venus when visible. You know, that blue point contains billions of humans, biosphere of millions of species, all recorded history, origin of life, now growing on two worlds. Emotionally, Earth is beautiful distant light, home of ancestors, but not your home. You were born here, Mars, under salmon blue sky, in 38% gravity, breathing thin but adequate air, adapted to cold and altitude. Earth is myth, history, origin story, genetic homeland. But Mars is home, soil beneath you, air you breathe, trees you climbed as child, ocean you swam in, life you live daily. Transformation complete not just geologically, breathable atmosphere, but psychologically, belonging to Mars, not just living on Mars. Two living worlds now, two biospheres. Humanity multiplanetary, not just physically, populations on multiple planets, but culturally, different planets claiming as home. Earth-Mars connection remains, trade ships, communication with minutes of light delay, conversation slow but possible, cultural exchange, family ties across worlds. But divergence beginning, Martians adapting evolutionarily over generations, larger lungs, more efficient oxygen metabolism, possibly becoming separate subspecies over thousands of years, developing unique culture, forming Martian identity distinct from Earth identity while honoring origin. You close your eyes, breathing Martian air, feeling Martian soil, listening to Martian wind through engineered trees, and feel peace. Not triumphalism, we conquered Mars. Not guilt, we altered pristine world. But peace. Satisfaction of patient work across generations. Achievement of noble vision. Expansion of life's presence in universe. Creation of second garden world. Sleep comes naturally here, held by transformed planet, embraced by possibility made real. Contemplate civilizational maturity. 2,000 years. Terraforming complete, though maintenance continuous. Comets redirected every few centuries to replenish atmospheric losses. Biological management ongoing. Climate fine-tuning never-ending. You're elderly now, 120 years old. Lifespan extended by medical advances. Sitting on porch, watching grandchildren play in yard. Mars born, adapted. Superior lung capacity, efficient oxygen utilization. Comfort in 38% gravity that would weaken Earthborn. "2,000 years ago, humanity still using Roman numerals, building with stone and wood, believing Earth center of universe. Now, 2 living worlds, continuous habitation from Mercury to outer solar system, fusion power abundant, but fundamentally same species. Still curious, still building, still transforming environments to suit needs, still looking outward, asking, what's next? Terraforming Mars demonstrated humanity capable of multi-millennial patience, planet-scale engineering, taking responsibility for maintaining life support systems, cooperating across generations toward distant goals. Skills necessary for managing Earth's climate. If we can terraform Mars, can surely maintain Earth. Expanding to other worlds, Venus next, terraforming harder but conceivable. Europa's ocean, Titan's atmosphere. Surviving long-term as species, multi-planetary redundancy protects against extinction. Maturing as civilization, thinking beyond quarterly profits, election cycles, individual lifetimes to geological, astronomical timescales where meaningful change occurs. Close your eyes, breathing Martian air, feeling Mars soil, listening to Martian wind through engineered trees. And think, we did this. Patiently, cooperatively, persistently, across time deeper than empires. We gardened a planet. What else might we do? You're lying in grass on transformed Mars, year 2000. Blue sky overhead, thin but breathable. Distant water sounds, stream flowing, ocean waves. Temperature comfortable, plus 15 degrees, light breeze. Earth visible as bright evening star, origin acknowledged, but no longer only home. Mars lives, green, wet, breathing. You've witnessed transformation across centuries, patient gardening of planet. Rest now in achievement. Sleep comes naturally here. Breathing slow, deep, easy despite thin air, adapted, comfortable. Grass soft beneath you, soil rich with organic matter accumulated over centuries. Birds calling in distance, Martian birds now, adapted species thriving. Insects humming, life surrounding you, embracing you, holding you. Mars transformed from frozen desert to living world through multi-generational patience you've imaginatively witnessed. Peace settles over you. Tomorrow, questions return, choices to consider, ethical debates to resolve. Tonight, simply rest beneath blue salmon Martian sky, breathing transformed air, held by transformed world. Whether humanity should terraform Mars remains open question. That we could, given patience, demonstrated through contemplation. Possibility explored, science understood, wonder felt. Now, sleep. Eyes close naturally. Sky disappears but remains in memory. Blue overhead, pink at horizon, earth bright in evening, stars emerging. Grass beneath you, wind through trees, water flowing somewhere distant, life present everywhere. Mars alive again after 3 billion years frozen, through human choice, human patience, human gardening across deep time. You rest as transformation rests, both complete yet ongoing, both peaceful. Sleep deeply now. Transformation watched, time-lapse experienced, centuries flowed like water. Mars changed from red to green, frozen to flowing, dead to living. Patient gardening across 33 generations, teaching patience, teaching rest, teaching trust in processes beyond individual lifetime. Dream of transformed worlds, or simply dream. Peace remains. Mars holds you gently. Sleep comes. Breathe transformed air. Rest in transformed world, held by deep time patience, embraced by possibility. Good night. Transformation complete. Millennium achieved. Breathable. Mars alive, green, wet, breathing again. Blue sky overhead, Earth visible, evening. "33 generations, patient work completed." Multi-generational patience, teaching deep rest. Cathedral builders across centuries, comparison holds. Patience for transformation mirrors sleep patience. Releasing urgency, trusting planetary pace rhythms. Ethical questions, preservation versus expansion, both. Should we terraform Mars? Remains open. Could we demonstrate it across contemplative millennia? Science understood timelines, grasped possibility, explored. Tonight, simply rest beneath transformed sky. Grass soft beneath soil, rich life. Water flowing somewhere distant, peaceful sound. Birds calling, insects humming, ecosystem thriving. you gently, breathing together. Temperature, comfortable breeze, gentle rest comes. Eyes closing naturally, sky fading memory. Transformation watched, time-lapse experienced, centuries flowed. Red became green, frozen became flowing. Dead became living through patient work. Sleep deeply now, held by possibility. Mars transformed you. Rest, transformation complete. Breathing thin air, comfortably adapted, peaceful. Grass beneath sky, above water nearby. Life surrounding, embracing, holding you gently. Tomorrow questions tonight. Simply rest deeply. Dream transformed worlds, or simply dream. Peace remains, Mars holds, sleep comes. Blue salmon sky, eternal, patient, transformed. gardening planets across deep time, teaching. Rest now, complete transformation witnessed peacefully. Two living worlds, Earth, Mars, both. Humanity expanded consciousness, multiplanetary, now rest. Sleep beneath blue Martian sky, breathing. Transformation complete. Rest earned. Deeply peaceful. grass, soft soil, rich life everywhere. Mars alive, holding you, gently sleeping. Patient gardening, teaching patient rest now. Blue sky overhead, earth visible, bright. Two worlds, two homes, humanity expanded. Sleep deeply, Mars embraces, peacefully holds. transformation, watched, rest, earned, sleep comes. Breathing transformed air, resting, transformed world. Deep time patience, embracing you now. Mars, green, wet, breathing, holding gently. Sleep beneath possibility realized, peacefully resting.